going to talk about factoring expressions. So this is going to be an extension on the distributive property, kind of like the opposite. So previously we learned that if I had 3x plus y, I'm going to distribute the 3 times x plus the 3 times y, and this is going to get 3x plus 3y. Okay? Now I'm going to start with 3x plus 3y and ask, what do they both have in common? They both have a 3 in common, so I'm going to bring the 3 out, and I'm going to leave the remainders on the inside. Okay? You'll see how to do this as we go throughout. Okay? So let's look at example number 1. Example number 1 says factor the expression 20 minus 12 using the GCF. So you have to think about what's the GCF between 20 and 12. So if you remember, to make a factor tree, I know I have 4 times 5, 2 times 2 times 5, and 12 is going to be 4 times 3, 2 times 2 times 3. They have a 2 in common, they have a 2 in common, so therefore 2 times 2 is 4. So the GCF of 12 and 20 is 4. So I'm going to bring the 4 out. What times 4 is 20? I know that answer is 5. Bring down the minus. What times 4 is 12? 3. So this is how I'm going to factor my expression. Okay? So now my final answer would be 4 times the quantity, 5 minus 3. Okay? Which makes sense because that's going to be 8, which is 20 minus 12. Let's look at the second example. Which expression is not equivalent? So let's think about it. 16x plus 24. Alright? If I'm going to distribute the 2 to this 8x, that's going to be 16x, plus 2 times 12 will be 24. So we know that that's not the answer. 4 times x is going to be 16x, plus 4 times 6, which is going to be 24. Therefore, that can't be the answer. 6 times 3x is going to be 18x, plus 24. That looks a little different to me. And the last one says 8 distributed, which is still going to give me 16x because 8 times 2x, plus 8 times 3, which is 24. So therefore, C is the only one that is not equivalent to 16x plus 24. What they're trying to show in this problem is that you can have the number after the quantity, after the parentheses, and it's still going to give you the same answer. Let's look at the next one. Example number 3. This is the last example that they have. Maybe I'll do a couple more examples with you. Let's see what they have here. This one says, you receive a discount on each book you buy for the electronic reader. The original price of each book is X dollars. You buy 5 books for the total of 5X minus $15. Factor the expression, what can you conclude about the discount? So we're looking at 5 and 15. What do 5 and 15 have in common? They had 5. So I'm going to bring the 5 out. 5 times 1x is going to be 5x minus 5 times 3. So it's saying that this, you buy a book for electronic reader, the original price is X. Okay, so the original price is X. We want to know what can you conclude about the discount. We can say that the discount was $3. This is the discount because here's the original price. This is the discount. And this is the amount of books I bought. Purchased. Okay, and so this is really helpful to us because if I just looked at 5x minus 15, that doesn't really tell me a lot. But if I know that x is the price of the books, I know that I'm subtracting $3 for each book, and I bought 5 books. All right, let's do one more example together. Let's factor. Let's factor 15 plus 35. 15 plus 35. So what do both 35 and 15 have in common? They have 5 in common. So what times 5 is 15? 3. What times 5 is 35? 7. That's that factor, okay? What if I had 15 plus 45? Okay, and I look and I see, oh, I know 5 goes in the both. So I do 5, and so this is 3 plus 9. Now I look at this. Is there a number that 3 and 9 have in common? Yeah, 3 and 9 have 3 in common. So I'm going to bring that out and multiply it by 5. Since I'm going to take out the factor of 3, I'm going to do 5 times 3, okay, which is going to be 15. 15 times 1 is 15, plus 15 times 3 is 45. So sometimes you could double factor if you don't do the greatest common, all right? What about 36 minus 28? 36 minus 28x. What do 36 and 28 have in common? Well, I'm thinking 36 and 28 have 4 in common, but let's see if they have anything else. 4 times 9, 7x. Notice I left the x in because that x is there, okay? Let's do a really hard one, all right? Let's do 24x plus 12x squared. So I see that in both, they have a greatest common factor of 12, so I'm going to bring that out. But what I also notice is they both have an x, so I'm going to put an x here. 2 times 12x is going to be 24x plus x times 12x is going to be 12x squared. Okay, so that's a really tough one. That's advanced, all right? So hopefully there's none like that, but if you're looking for a challenge, I can give you a couple problems like that so that you can take out both variables and the greatest common factor. But mainly you need to know problems like 15 plus 3x, and you need to know 36 minus 28x, okay? If you guys have any questions, let me know. I'll work through these problems. You should be okay. If you have any questions, definitely let me know. Good luck, and I'll talk to you guys later.